Hello everyone. We're going to work a Ford F-150 problem. So we worked this in class, but I'm going to work it out for you guys online. I gave everyone this problem here with all that data. Sorry for the monstrous numbers, but I thought it was a good problem to work. On part A, you see it says draw a scatter plot, calculate R and the least squares regression equation, and plot the line on the graph. So I kind of wrote over that part because I needed the space. But we took some time, it took a little bit to graph that. And for the sake of space, I stopped writing thousands at the bottom. So maybe when you do your graph, I'd write miles driven, maybe add a little like thousands note. And then you can just number, say, by, I think we went by 10,000. Every dash is 10,000 miles. So I went 5, 15, 25, all the way up to 145. And then on price, you could do the same thing. You could say that's in thousands. So I started at 9,000, and I went by 3,000 every dash, all the way up to 42. And if you notice on the data set over there on the right, we found our min and our max for both lists, and that helped us make our scale. So hopefully making a scatter plot's good. You might pause it and just make your own. So from there, we needed to calculate R and the least squares regression equation. And then we're going to plot it on the graph. So I'm going to go to my calculator. So make sure you type it all in. If you haven't yet, you might type it in. So hopefully you're holding your calculator. You can go back to you can rewind it a little bit, look at that data set and type it all in and pause it. So I'm going to go ahead and do it here. So we hit menu, stats, stat calc, and 4 for linreg. If you're using the 84, you press stat, go over to calc, and you want the 8th option and just hit calculate. And you should get the same results that I get. So I named my two lists A and B, hit OK, and here we have our data set, our estimates of least squares and correlation. So right now I'm highlighting correlation, negative 0.8150, and right above it we have R squared. We haven't gotten to that yet. We'll talk about that soon. At the top we have A, that's our y-intercept, and then we have B, that's our slope, negative 0.1629. So let's write all that down on our problem. I'm going to go back, and we had R as negative 0.8150, A is 38,257. That's the y-intercept, so if you need to make a note, that's our y-intercept. The slope is negative 0.1629. And at the very end of this part A, I wrote over it, it says plot the line on the graph. Now before I do that, it's important that you note like how to write this least squares equation. Because in the notes, right before we worked this problem, I had this written on the board. And while that's perfectly correct, I want you guys to use the context when you write it. AP says it's defining the variables. So y is the price. So I want to say price hat equals 38,257.1 minus 1629 parentheses. I'm going to get rid of that min right there so we can write miles driven or just miles. And that right there, how I just wrote that, would be writing the least squares regression equation with the variables defined. And then next we want to plot it. So what I do is I pick two coordinates. So you could go pick the min and the max. So I'm going to use x equals 4447, and the y hat value is 38257.1 minus 1629 times 4447. So type that into your calculator, see what we get for y hat. I'll let you pause it for a second or type away. I'm typing it myself, and I got 37,532.7. So that's a price, so that's dollars. That's the predicted price given that a truck, a Ford F-150, has 4,447 miles on it. Now, just for the sake of giving us a nice range to plot a point with, I'm going to pick the max. So you can pick any number in the data set though. But 144,162, I think that was the max. Plug it in. I'm running out of room here. I think we'll barely make it. 257.1 minus 1629 times that x value, and I get a predicted price of 14,773.1. So that's $14,000. All right, so I want to plot those two coordinates on the graph, and we have successfully plotted our least squares equation. So that's 4,447, comma 37,000. So that's about, it's just like right below that red dot. So that red dot right above it is the actual. Make sure I'm accurate there. So we got 37.5. Yeah, it should be right below it because the actual was 37.9. So I don't know, that's probably still too far under it, but that works. And then the other is 144 and 14,000. So that's about right there, I believe. Yeah. And then connect the two green dots. And that's our least squares equation. Hopefully that makes sense. You really, really need to pick two coordinates, get the estimated or the predicted price in this case, and plot those two coordinates. Where people go wrong is they just guess and they draw a random line. When I'm grading this, I want to see two specific coordinates that you plotted it to, if you want credit. If I just see a random line with no dots, I'm going to count off. So I need to see two specific dots that you went to. I need to, at minimum, see the two coordinates that you're plotting. So I would prefer you to show this work right here. But at minimum, I need to see the coordinate, and then I need to see the two dots on the scatter plot and the line connecting them. All right? If I just ask for the equation and to define the variables, that's this right here. So two different things. I may say, what's the least squares equation? Variables defined, that's the first green circle up there. And then if I say plot the line on the graph, I need to see two specific coordinates graphed on the scatter plot. All right, I'll define y-intercept and slope in the next video. Bye, y'all.